So hi, what is this? This is an LCD for Arduino. It came with this pen, and actually this is going on any Arduino Uno or Arduino Mega. You can install it on both. This is a shield, so you put it on the Arduino itself, and then you have to load library, of course, in order to make it to work. It was not simple to make it to work to what I need, and the library that I downloaded was not installed, and the header file, many problems, but eventually it took me about an hour to fix all the library issues, and then I could make it to work. What is special about it is that it is also an touch LCD, so you have both function. You can write something that you want or display picture or anything, and you can use the pen in order to press and then do something with it. So eventually I bought this in order to make a project that I want a long time to do, and this is for spot welder, to build a spot welder alone, and I want to have ability to control. And if you've seen my previous videos, I already said that it is very basic function, because you just need a pulse, and the pulse is usually between 1 millisecond to maximum 100 millisecond, and this controls the discharge from the supercapacitor, from the battery, to the spot that you want to weld. So now, after doing all the things, I want to show you how this is working. So I've already this is the second one. So this is the second LCD, and I will show you how this is working. So when you press, when you put the power, so you can see you have a plus and a minus, and you have a display in millisecond. I took many libraries and did an integration in order to make it work to what I need. Again, it was not very simple, a few hours of work, and now it looks like it is okay. So I have the plus button and the minus, and when I'm pressing, you can see the number is the milliseconds that I can discharge take the current from the supercapacitor to the welding point. Also, I can press continuously, so it is going up, or continuously on the minus it is going down, and when it reach 0, of course, maybe I should stop it at 1, because you don't want to do 0, but this is very simple change, and the maximum is 100. And then if you want to do the spot weld, you just press the fire and you have a boom. You see the boom is sending the pulse out. And now what I need to do, last thing, is to check that my code is working. So the output is here. So I will now connect it to an oscilloscope to see that it is sending the correct pulse out. Okay, so now everything is in focus. I put it on the oscilloscope, and now let's test that it is working properly. So I will go to 1 milliseconds, and we will test that the pulse is okay. The scope is connected to the output here, and now we will do the test. So we have to do the boom, so pressing boom. So as you can see, there is a pulse. I will open the scale, and 1 millisecond, 1.02, very impressive. Let's go for 5 milliseconds or 7 maybe. So again, I'm doing a trigger, and boom. So the reading is channel 2, if you can see, 6.01 millisecond. Very impressive and very good. So we'll go now to another number, 25, again Boom. Too much on the screen, so I will move the trigger and do it again, and boom, 25 milliseconds. As you can see, very accurate. We'll go now to the maximum 100 milliseconds and test it again. So single sequence, and we have exactly 100.0 milliseconds. So overall it is working perfectly. Of course, now need to connect it to the MOSFET, and to do it automatically I don't want to press the LCD. Maybe I want in some of the application, but I want it to automatically detect the conduct and then do the pulse. But it's very nice that I can control it from the LCD with a touch. By the way, this is a bug because I'm not deleting the last numbers, but it is now 33 milliseconds. I will fix this bug. When you test, you always find. You can see that it is 33 milliseconds, not 330. I know where it is. I will fix it now and do a very last test to show that I can fix it, and then we will see that it's okay. Okay, so fix this bug. I will show you. If I'm going to 100 and then we'll do the boom, we have exactly 100 milliseconds, and when I'm going down, now it is fixed, and 74. Let's do another test. 74 milliseconds, exactly 74 milliseconds. So the pulse is going out, and now I can continue with the MOSFET and the power and the charging for the supercapacitors, and doing a voltage check that it is not charging over the allowed voltage for supercapacitors. I will share my code later, and I will explain how to use the libraries. So thank you and bye.